Hi everyone, welcome to the class. In this video, I will show you using drawing to visualize the concepts of reducing or expanding a fraction and finding the least common denominators. In the math class, you are always asked to simplify your answers. Simplify. Now, simplify this word. You may find it everywhere in your math textbook, homework, or test. Now, depends on what type of subject or content you are learning when you are taking math class. In different situations, simplify has different rules. Now, here, to simplify a fraction. So today, I'm not going to talk about how to simplify a square root, how to simplify anything else. I'm talking about how to simplify a fraction. Now, how to simplify a fraction is to reduce the fraction to the lowest term. What lowest term means? Means you cannot find any common factor. No common factor. Between numerator and the denominator. So here, 33 equals to 3 times 11. 55 equals to 5 times 11. It's obvious, you can see that 33 and 55, they have a common factor, 11. Common factor is 11. Then how you reduce? I will show you why it's still equal. Okay? Very important when I show you a method. Yes, you learn the method and learn how to do it is very important. But before you do that, you want to agree with the method. How to agree? You want to make sure it's equal. If that's equal, then you keep going. If you don't believe it's equal, then you have to relearn to make sure what's right. So 33, because they have a common factors, so you can divide the common factor, so it becomes 3 over 5. Now, right now I'm not going to show you the concept yet. Here I go over the first page, tell you overall what we are going to learn, and then I will go back to explain the concept of how to reduce the fraction. Okay, so the method is you divide the common factor. That's the way you reduce. And to the lowest term is you need to divide all the common factors. Then you have the lowest term. And pretty soon I will show you why it's equal. Okay. Number 3, to expand. Let me change the color. To expand a fraction. Expand a fraction is to enlarge a fraction's denominator and the numerator. So if you take a look on the second example here, when you divide, they still equal. So how about you multiply back? If you multiply back, then they're supposed to be equal. So far I can explain this way, but yes, Next page, I will use drawing to show you, to visualize the two fractions are equal. 3/5 equals to 33/55. So no matter you multiply to equal or you divide to equal, they're supposed to be equal. Okay, so next, after you learn how to reduce or expanding a fraction, then we can use these two skills to make the denominator a specific number. What a specific number means? 2/3 plus 1/2, you have two different denominators. And I would like to make it a special number 6. How can I find this number 6 to be a specific number? We call this the least common denominator. If you are not going to find the least common denominator, then you can change 3 and 2, these two denominators, to any number you prefer. And how to do that, I will show you later. Okay, but because you are allowed to multiply the same number or divide by the same number, by doing this, you can make a 3 and 2, these two different denominators, become the same denominator. Therefore, when you have same denominator, it's easy for you to plus them together. In this video, I'm not going to show you how to add two fractions. But obviously, when you have same denominator, 4/6 plus 3/6, when you have same denominator, it's something like a 4. You have 4 apples plus 3 apples. Right now, this is 1/6, this is 1/6, right? You have something, you can combine the like term. So you have 7 apples. Okay, so it is 7/6. Now, so far, that's overall we are going to learn. If you say, oh, teacher, you say so fast, I don't quite understand how to calculate it yet. Don't worry. I just talking about the overall what we are going to learn. I have not started teaching those skills yet. So with these two methods, reducing, expanding a fraction, then you can use these two concepts to find the least common denominator. After you have the common denominator, it's easy for you to plus, minus, or even when you need, you can multiply or divide. Okay. Okay, so let's go to next page. Visualize fractions. If I share the whole thing, I will say this is 1. 1 equals to 1/1, right? Let me erase because I need a space to write. So 1 equals to, if I cut in half, then the whole thing you have 2 parts, right? 1/2 plus 1/2 actually is you plus together become 2 over 2. 2 over 2 is 1 because you want the whole thing. So let me erase this again. So I would like to say 1. You can say it's 1 over 1. You have the whole thing and you want the whole thing. This is whole. And this is whole. So it's 1. Obvious. Now if I cut it in 2, this 1/2 and the 1/2, I still want the whole thing. How can I do that? Then it means you want the 2 over 2. Okay? So it's equals to the whole thing. This whole thing is same as this whole thing. They are the same thing, right? So obvious, you can say that 2 over 2. Same thing, the whole thing, you cut to 3 pieces. 1/3 plus 1/3 plus 1/3. You have 3/3. So it's equal to 3/3. Still the whole thing. And you may keep going to next one. That's 1/4, 1/4, 1/4, 1/4. You have 4/4. Still the whole thing is 1. So let me show you the whole picture. 1/5 plus together this 1/5, 1/5, 1/5. Plus together you have 5/5. 6, 6. So those photos or the pictures or the drawing I show you here, first thing I want to show you, yes, you can expand the fraction. You can expand the fraction and they are all equal. How can you expand the fraction? Let's go back to here. Okay. 1 over 1, if you cut the whole 1 to 2 pieces, then you need both of them. So if you cut the whole thing to 2 pieces, then you need to have all of them. All of them means 2. If you cut the whole thing to 3 pieces, you still want all of them because you want the whole, right? So 3. So 1 over 1 equals 2 over 2 equals 3 over 3 equal to 4 over 4. If you cut it into 5 pieces, you want all of them. So it will be the whole thing. So that's 1. And from this example, it's obvious. You understand? If you multiply same number, if you multiply a number, for example, 1 over 1, you multiply a number 3 to the denominator. In order to keep equal sign equal, you need to multiply the same number to the numerator. So in order to keep the equal sign equal, you need to multiply same number to both denominator and the numerator. So that's how we expand a fraction. And go backward, if you divide by the same number, that's how you reduce a fraction. So in the first chart, I would like you to write down equal. When you write down equal, means you agree. If you doubt, you don't understand, please go back to the video and watch the video to listen to my explanation. Now, another part is I would like to help students with drawing. I already show you my drawing, but on the test, I'm not going to draw for you. And why drawing is so helpful? Because pretty soon, I will ask you to compare some easy fractions. You can just visualize by drawing and visualize which one is bigger, which one is smaller. And also, if you know how to draw, then it's easier to understand the concept. So let's try this way. 1/1 means the whole thing. Okay, wait. Okay. Let me pretend this is a whole thing. Okay. Okay. 1/1 is you cut the whole thing in one piece. Means you didn't cut. So that's a whole. Outer whole. Okay. And the 2/2 you cut in half, and you want the both of them. Okay, 1/1 means you don't cut, and you want the whole thing. 3/3 you cut in 3, so roughly. So on the test or on your homework, because we are all human beings, you cannot draw the graph like I did earlier. So, but it's good. That's how you learn the concept. Okay, 4 you may cut in half and cut in half, so you have 4 pieces. You want them all. That's the same thing. 1 equals 1/1, 2/2, 3/3, 4/4. And how you do 5/5? I would suggest you roughly make 4 pieces. But the 5/5 you want to cut to 5 pieces, so it may be smaller. Okay, and then the rest part we can cut in half. And cut in half. Cut in half. Do you see that? 1, about, right? 2, 3, 4, 5. So if you have an even number for the denominator, you can cut in half, keep going. But when you don't have even number, even number to draw the picture, so you roughly save a little piece, and then the rest you can you have an even number, you can divide by 2, divide by 2, divide by 2. So 6 is an even number, so you can divide by 2, right? Divide by 2 here. After divide by 2, you want to cut into 3 pieces. 3 pieces will be smaller than half, so I will say here 1/3, 1/3. So 1, 2, 3, 4, 5, 6. Okay, so how to draw a fraction is very important. So for example, here, I ask you to draw 1/2, so you cut in half. And only shade only 1 out of 2. The whole thing is here, you cut in half, this 1/2, this another 1/2, you only shade 1 part. Make sense? Now, if I ask you to expand the fraction, originally you have 1/2. You have 1/2, right? How you expand? You may do this way. You can cut in 2. Okay? Now you have 1, 2. So you cut to 4 pieces, and with the same size of the shading, you need a 2. So same thing when you cut in 2. When you cut in 2, everything become double. You times 2 times 2. Okay? Now with the same thing here, for example, if I want to cut to 6 if I would like to times 6. So originally I have half here. And I would like to times 3. So let me do this way. I times 3. Oh, I want to change color, sorry. So about here. So right now I have 1 over 6. 1 over 6. 1 over 6, right? 1 over 6. 1 over 6. 1 over 6. And I would like to have 1, 2, 3. So it's 3 over 6. So I multiply 3, multiply 3, I have 3 over 6. So the rest, I will try, let me try one more example, and you can find, you can go home try more by yourself. So, for example, this 2/3. 2/3, I make this. I cut in 3. And the 2/3. 2/3. 1, 2. Now, if I want to times 2 times 2, so I cut in 2. So I have 1, 2, 3, 4, 5, 6, right? 6. And 1, 2, 3, 4. 4 shaded. See? And if I would like to times 3, you can times 5, but we are just learning the concept, so we don't need to make it too complicated drawing. But you want to times 3, then probably this way, right? Okay. So times 3, then you have 3 times 3, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 and 1, 2, 3, 4, 5, 6. 6 shaded. So 2 times 3, 3 times 3. And I forgot a very important thing I would like you to do is make sure you write down equal sign. Means you agree. Yes, yes, it's equal. Yes, yes, it's equal. Okay? So you understand if you want to expand a fraction, you can multiply the same number to denominator and numerator, and it should be equal. Okay? And go backward. If you divide by 5, then they are still equal. You go back to 3/4, right? Now here, the method is pretty easy. You just multiply the same number to the numerator and the denominator, or divide the same number to the numerator and the denominator. So method is pretty easy, but I would like you to draw the picture to make believe. Make sure you agree with the method I just showed you. Okay. So we have so many examples here. I think you can. Let me make this one smaller so you can make a screenshot, and you can make a screenshot to of this chart, and then you can try. Okay, you can try to draw your shade. Okay, shade, and if times 2, if you times 2, then everything divide by 2. Everything. Okay, each little part divided by 2. So you have this. So 2 over 8 when you times 2, everything divided by 2. And it should be equal. So you can keep going to finish the whole chart by yourself. And reduce the fraction, same thing, you already have the idea, it's just backward. So we can easily write down 6, you can divide by 3, right? You can divide by 3, so you have 2 over 2. You can divide by 2, you can 3 over 3. You can divide by 6, 1 over 1. Probably there's nothing you can do, okay? And they are all equal. And you can draw a picture 6 over 6, divided by 2, 3, and 1, 2, 3, 4, 5, 6. Okay, and then you can 6 over 6, you can consider is 2 over 2. That's one way, right? And you can consider is is 3, 1, 2, 3, 3 over 3. You can do this way, right? And 1 over 1 is the whole thing. Okay. So the rest of the chart, you may do the same thing. Let's try, we try 6 before. How about we try 10? 5 over 10. 5 over 10. Let's try this one. Okay. 5 over 10 because it's even number, so you divide by 2, and then you want to separate to 5 pieces here. And you want to count 1, 2, 3, 4, 5. So 5 over 10, 5 over 10, 5 over 10 obviously is 1 over 2. Yes? It's 1 over 2. And if you divide by 5, it's equal. Okay? And then let me try. How about 3 over 12? 12 is an even number and an even number. So each piece you want to divide by 3. Each piece you want to divide by 3. Okay, divide by 3. Divide by 3. Divide by 3. Okay, and you want the 1, 2, 3. Okay, so you can see that is, oh, I didn't change the color. So it's 1 out of 1, 2, 3, 4. 1 out of 4. So you divide by 3, you have equals to 1 over 4. Again, I think learn how to draw, to visualize the answer is very important. Okay, so please make sure you practice. Now, the last one more example is 0 over 1. 0 is nothing. So nothing is nothing. Nothing you want to cut to no matter how many pieces. Doesn't matter. Okay? You want to cut to 16, it's still equal. Doesn't matter, just 0. Okay? So you want to 16 divided by 16 or 16 divided by 6. Doesn't matter. It's always numerator is 0. 0 means nothing. Nothing. So 0 is always 0. So very important extra information to you. 0 equal to 0 over 1 equal to 0 over 2 equal to 0 over 3, however you prefer 0 over 16 doesn't matter. Okay. And the one extra thing is if you have 0 on the numerator is 0, but how about if you have 0 on the denominator? We don't talk about that right now. If you are elementary school students, if you are high school students, your teacher may teach you in the algebra, okay? But make sure when I say equal to 0, the 0 is on the numerator. On the numerator, okay? And you never want to put the 0 in the denominator. It's a big trouble. So we so-called undefined. Undefined so far. Okay, so don't do it. It's different. Okay. So after you agree, reducing or expanding a fraction, they are all equal, then we may try to, and also you already learned how to draw and shade a fraction. Then we can try to compare fractions. How to compare fractions? Let me make the graph bigger. Okay. If you have a whole thing, you cut in half, and you only shade 1. Okay, and here you cut in 2, and you want the 2 of them. Obviously, right hand side is greater. Okay, this means greater. This smaller. Because you can see this side smaller and this side greater. Okay. So you may draw the picture to compare. That's a good way to understand. Very important way. But sometimes when the number become very big, or in this case we have same denominator. If you have same denominator, it's easy to compare. You just compare the numerator. Then you can decide which fraction is bigger. Same thing when you have same denominator and you have this numerator is numerator. This numerator is bigger. Then we just compare with the numerator, right? And you may draw a picture to make a belief. 2 of them, and this is only 1. Obviously, 2 greater than 1. So when you have same denominator, you only compare with the numerator. Same denominator, you only compare with the numerator. And you can draw the picture to believe it. Okay? So same thing when you have same denominator. Everything is easy. Okay? Now when you have different denominator, do you say 3 greater than 2, then is this? Then it's wrong. Okay? So when you have numerator, when you have same denominator, you compare the numerator. So let me write down for you. When you have same denominator, you compare the numerator. However, when you have same numerator, you still compare the denominator. Okay, you compare you choose. I will say that. Okay. You choose the smaller denominator to be a bigger fraction. Yeah, greater. I don't know how to say it right. Yeah, greater fraction. Okay. So, let me see. So let me use this one to show you. If you have same numerator, then you choose the smaller denominator to become a bigger fraction. When you have same numerator and this denominator is smaller, then you say this one is bigger. It's pretty obvious. The concept is, if you have smaller denominator, means you cut to 2 pieces only. And if you have bigger denominator, means you cut to 3 pieces, means a smaller piece. So this is a bigger piece. This is a smaller piece. Like if you have pizza, if you cut in 2 pieces, then each piece is a bigger piece. If you cut to 3, then each piece will be a smaller size. So depends on the same number is numerator or denominator. You have different way to compare. Now again, when you have same numerator, you only need to compare with the denominator. Denominator smaller means the piece is bigger. You have bigger piece. And this one, let me draw the other way. Okay. Okay. So if you cut into 5 pieces, it's smaller. You cut into 4 pieces. Each piece is bigger. And then you want the 3 of them. You want the 3 of them. Okay. So this definitely is bigger. Okay. So you can go home, try to draw. So in the beginning of this video, I said I would like to use drawing to share the concept with you. You need to focus on learning how to draw a fraction to make sure you understand the concept. So keep going, you have more and more comparing. Now, if you have different numerator and the different denominator, then the above rule from last page, I say if you have same numerator, then you compare with the denominator, which one is smaller. If you have same denominator, then you compare with the numerator to see which one is bigger. But if you have all different, then such rule don't apply anymore. So how you do that? If you are the beginning learner, if you are a elementary school student, you don't know how to do subtraction to compare. Basically, you subtract to compare, or you find the common denominator to compare. But if you are a beginning learner, you are an elementary school kids, you first time learn the fraction, and then you will see the homework ask you, which one is bigger? Wow. Then you need to use concept, or I would say suggest you draw the picture to understand. Okay? So 1/3 means you cut into 3 pieces and shade just one. And the 2, you want all that. So basically this is one whole thing. And this is just 1/3. Obviously this is bigger. When you draw a picture, you believe it. Okay? Yes, we have other way to do it. But when you are first time learn the fraction, you don't know how to calculate. So drawing is very good way. Okay? And I believe you are the beginning learner, the question won't be too hard. So you can easily draw a picture. So therefore, drawing a picture here is very, very important. Okay, here, 2/3, you want the 1 and the 2. Okay? And the 1/2 here. Now, if you want to compare these two, kind of hard. So I will say, how about from 2/3, we try to find 1/2. So you cut in half, and this is 1/2, right? And the 2/3 is way bigger. You can see that 2/3 is here, and the 1/2 is only the green part. So obviously, 2/3 greater than 1/2. You can try to draw picture again. Let me try one more for you. 4/5 and the 3/4. So let me see. We can use a lighter color. 4/5. So we cut in in 5 pieces. And I will shade the 1, 2, 3, 4. And the 3/4 here, right? And I choose 3, 1, 2, 3. But it's not easy to compare because they are separate. So I would suggest in this case, you draw this picture 3/4 in the same location. You divide by 4. So divide by 2, and divide by 2, and divide by 2. And you want the 3 of them. 1, 2, 3. Wow, too close, right? Because we are human beings, and when you draw a picture, it won't be accurate because we hand drawing. When you hand drawing, will not be accurate. Not accurate. So when these two numbers very close, then you really then need to learn a way to calculate. Okay, we say we want to make them to have same denominator. So let me erase. Okay. So when drawing is hard, why the drawing is hard? Because these two values very close. They're almost equal, but not equal. Then you want to compare a little bit difference. It's hard. So how can you make them same denominator? You can say this is 5, this is 4. Pretty simple. If you can multiply 4, remember I say you need to multiply the same number if you want to multiply 4 to the denominator. You need to multiply 4 to the numerator. And then here you want to multiply 5. So you have both. So you multiply 5 to numerator and the denominator. By doing that, both denominators have the same factor. 4 times 5, 5 times 4. So this will be 16 over 20. This will be 15 over 20. When they have same denominator, you can make them to have same numerator, but I would like to have same denominator. Because when you have same denominator, you only compare with the numerator, which one is bigger, then the fraction is bigger. So 16 is greater than 15. You can see that their difference is just 16 compared to 15 is 1, and the denominator is 1 over 20. 1 over 20, if you really want to draw a picture, is really, really small. Very, very small. Very small. Okay? And by our human drawing, you won't see the difference. They almost squeezed together. They're almost the same. Okay? So finding you expand. So what I did is I expand fraction and compare numerator. Okay? Expand the fraction, the denominator, and the numerator, and I compare the numerator. Now these two, let me see if I can draw. To understand, then I will draw the picture, right? So cut in 3 pieces, and I shade the 2. And the 5, and I choose 3. 1, 2, 3. Again, it will be very close, but let me try to draw 5. 1, and divide by 2. This divide by 2, and 1, 2, 3. Looks like, according to my drawing, looks like pink color is greater. Looks like that. But because I don't trust my hand drawing, so I would like to calculate. Same thing. You have 3 and 5 for the denominator. I want to make them to have same denominator. So I multiply 5 to both numerator and the denominator. So I have 10 over 15. Same thing, I multiply 3 to both numerator and the denominator. So I have 9 over 15. You can see 10 and the 9, very close number, but the 10 still greater than 9. So I guess right. Okay, or my drawing is almost accurate. But when the numbers are so close, drawing to compare is not a very perfect choice. Okay, so the rest, I will say I multiply 6. I have 6 over 30. This one I multiply 5. So they have same denominators, 30. Then obvious 20 is greater than 6. Okay. This one I can draw a picture because if I reduce, I divide by 2. Divide by 2, I have 1/2. 1/2 is this big. But the 6 over 7 is very, very big. So let me 6 over 7 is almost 1, right? 1, 2, 3, 4, 5, 6. Almost 1. Compared to half, obviously this is greater. But you can multiply 4, 24 over 28. You can multiply 7, You have 14 over 28. So 24 greater than 14. Yes, obvious that. Okay, so you can try more examples if you want. Okay. You can try more examples to you either draw a picture or you multiply to have same denominator. Then you can compare the numerator. Now, in the end, finding common denominators. When you have addition, subtraction, or comparing, if you learn how to finding common denominator, then it's easy. Now the problem is the earlier examples, I just simply multiply 2 denominators together. I multiply 2 denominators together, then I can have same denominator. So I multiply 8, and then I multiply 6. So 40, 42, so this one bigger. Less easy to calculate. The problem is if you have this one, 1/5, 2/3. Yes, the denominator is not too hard. The denominator is small. So, like I did earlier, 5 and the 3. I want the 3 here. And the 5 and the 3, I need the 5 here. Okay. Then I have 3 over 15. This is 3 over 15. And the 10 over 15. If you want to compare, you know this one bigger. If you want to add, you have 13 over 15. It looks like pretty easy. But if you have a bigger number like that, do you want to have 1 over 5, 5, 5 plus 2 over 3, 3, 3? And then do you really want to multiply 3, 3, 3, multiply 3, 3, 3? I don't think that's a good way to do that. And yeah, so you multiply 5, 5, 5, multiply 5, 5, 5. In this case, yes, maybe you can do that because if you just don't care what's the denominator, you don't care to multiply. And the numerator looks like a small. So you have 3, 3, 3 plus these two multiply together. Some number very big, right? Anyway, yeah, you can calculate, but number is very big. If you only want to compare, then obviously right hand side is bigger than left hand side. I know if you want to compare this one bigger than that one, but if you want to plus them together, then the number too big. The number too big. Okay, so what's the correct method? So right now I'm going to show you how to find the common denominator. Basically, how to find the least. Find the least common denominator. How to find the least common denominator? Yes, I find the common denominator, but it's too big. Too big. Make the whole fraction very, very big. Too big a number, not easy for calculating. Yes, right now you say, teacher, I can use calculator. Yes, you can calculate with a big number, and then you need to reduce your answer. If you make a number big and then reduce, you make too much work for yourself. Okay, so we want to be smart. Be smart. Don't do that. Okay, don't make too big numbers. So the correct method, is step one, factor to the prime. Okay, if you are elementary school students, you are beginning learner, you don't need to learn this part, but you can come back to this video when you learning higher level of the math. Okay, so this part is for students who already learn how to addition, subtraction, and try to find the least common denominator. And the factor to the prime is 25. You can divide by 2. We don't consider 1 is a prime number, but you can do that. Let me not say factor to the prime, just a factor. Okay, factor. So 25 is 5 times 25. And the 2 times nothing, 3 times nothing. So you have 5 times 5 is 25. So you factor. So you can see here 2 factor 5 and the 5 and the 25 and the 1. 1 and the 15 you can factor, just the factor. And the 2, this is not even number, you have 3 times 5 is 15. So do you see they have common factor? Do you see the common factor? They have one common factor, 5. Okay, then because you have common factor 5 and ignore these two, basically this number is 5 times 5. This number is 3 times 5. Okay, so 25 is 5 times 5 and 15 is 3 times 5. Let me erase those marks so we have space to show you the work. Sorry. We don't want the too big a number. Okay, step 1, we factor. So factor, you can use the method starting from 1, 2, 3, 4, 5 to guess what's the right factor. Okay, and then 25 is 5 times 5. 15 is 3 times 5. Then what should you do? You rewrite this fraction 3 and 2. 25 you change it to 5 times 5. And 15 you change to 3 times 5. Okay, so compare these two. What's the difference here? They have 1, 2, 2 5s. Here you have only 1 5, so you multiply 5. Make sure when you multiply a number to the denominator, you need to multiply a number to the numerator. Okay. Another situation is you have 3 here, but you don't have 3 here, so you multiply 3, 3 here. Same thing, when you multiply 3 to the denominator, you need to multiply 3 to the numerator. Okay, now after that, we can calculate. Well, the color is not good. Let me change color. Okay, so I have 2 fractions. Numerator 9, denominator 25 times 3. 25 times 3, 75. And this should be the same thing. 553, 553. You don't need to calculate again. They should be same denominator because we are finding common denominator. So same denominator. 2 times 5, 10. So plus together, you have 19 over 75. If you need to reduce, you have to reduce. Okay. In this case, we cannot reduce. So this is our final answer. Okay. And if I ask you to compare, if I ask you to compare, then you do the same thing. Do the same thing, and then it's not multiplication. Okay. You do the same thing. Do the same thing. You do the same thing, then 10 greater than 9 because they have same denominator, right? So either plus or compare, we use the same method. Okay. So I will give you one more example, then we are done. Because my video will never be a training calculating class. I focus on show you the concept of the method. So this is the common denominator. Okay. Okay, so wait. So this one, the common denominator is 75. So you have 75, 75, and the numerator is 9 and the 10. So you have 19. So I complete the first example here, and then I will show you one more example. Then I think that's the concept. Complete the concept, and you need to go back to your homework, your school homework, to find more examples to practice. Okay, now go back to the very big number, so you factor. So factor 555 equals to 5 times 111, and the 333 equals to 3 times 111. Looks like they have a common factor. So this one plus this one, you have 5 times 111, 1. And the 2 is 3 times 111. So these two are equal. I just change 555 to 5 times 111. Okay. Then comparing these two, they have the same common denominator. So you don't need to, they have same factor, 111. So don't multiply 111 again to prevent the number. If you multiply the whole thing 3 times 111, I say this is not a smart choice. Agree? Not a smart. So since this one, 555, you have 111 here. 333 has also had 111 here. So we just ignore 111. Don't multiply them again. And I will suggest you multiply 3. Okay? And here, the second fraction, you don't have 5 on the denominator. You want the same denominator, right? So you only need to multiply 5. So you have 15 multiplied 111. My example is still too big, I agree, okay? But I just want to show you most of the time you don't just multiply two denominators together. If you multiply two denominators directly multiply together, the number will be way bigger because you multiply 111 twice. Okay. So you have 15 times 111. So 2 times 5, 10. If you want to compare, then this one greater than this one. If you want to plus them together is 13, and what's the numerator? 111 times 15. 5, 5, 5, 1, 1, 1. It's not hard to calculate. So 1665. Okay. Now the final word I want to tell you is, after I calculate, everything is correct, right? I finding the common denominator, the least common denominator, because I don't multiply 111 two times. Okay, so I only multiply 111 once. Okay, but in the beginning of this video, I said you need to simplify. Simplify your answer. Always. So do you believe you can simplify? Because 13 is just 13. You cannot factor 13. So I will try 1665 divided by 13 to see I can simplify or not. 36 to 26. Wow. 105. Can I? 5. Can I? 105. Can I? Oh, cannot. So this 1665 is not a 13 times anything. If not, you cannot factor to 13. You cannot reduce. So then you always have to try to simplify. If you can simplify, then you have to simplify. But this case is you are done. Then this is the final answer. You plus them together. Okay. So I'm done with the concept of this the common denominator, and the concept of this common denominator. The most important thing is you don't want to multiply same factor twice. Be smart, okay? And for the concept, another concept I focus for this video is you use drawing to believe the fraction you expand or the fraction you reduce, they are all equal. So another important thing is you need to make sure you write down equal sign and you understand whenever you change the fraction either by reducing or by expanding, you need to make sure it is equal. Okay? You want to make sure whatever you did is equal. You won't change the question. Equal means you don't change question. That's very important. Okay? And go back to, so this is how you draw. And go back to our very first page. The most important thing is simplify. Okay? And I use drawing to make sure you visualize the concept. So on my first page, let me make it smaller so you can, okay, can I make it smaller? Okay, so you can make a screenshot and keep in mind my 1, 2, 3, 4 key point, very important concept. Make sure you read them again. Okay? So see you next time. Bye bye.